Welcome to the Cosmic Pie. I am your host, Dwayne Barkhouse.
And I'm Robert
This
Moore.
is episode 25 of season 4, Robert. Halfway
Yeah.
through the summer, old buddy.
Is it? Sorry, that probably came through my mic.
I hear that too, Robert.
This
is episode 25. Okay.
Sorry about that.
There we go. Now we don't hear it no more.
Yeah, I muted where I've got it watching over here, my second monitor.
We are trying.
So I can kind of see the
And
chat.
we are doing some new arrangements tonight. We'll see how it works. But Robert is not where he usually is. He's in some tropical paradise. I see a wharf behind him, clouds in the sky. It looks like either a sunset or a sunrise, depending on where you are, Robert, in the world. I can picture myself just taking photos, laying on the beach, enjoying the sunrise, drinking a bottle of water, of course, so we could keep it clean. Now, speaking about keeping it clean, Robert, you want to go ahead and do the disclaimer?
Sure. So as always, the opinions and views expressed herein are those of myself and Wayne. They in no way reflect the opinions of University of North Dakota, College of Arts and Sciences, Department of Physics and Astrophysics here at UND. It's just us. You'll have to come at us, folks.
And as hopefully you noticed, we do have a live chat feature that's running. So if you have any comments or questions, and we're always dying for questions, not literally, but we always like to have your questions, and you can stop us in the middle of our narrative, and we will try to answer the best that we can. And so please use that. The other thing to mention, of course, is because some people only watch the first few minutes or so, to capture those people, please don't forget to give us a thumbs up. Subscribe if you haven't subscribed. And we also upload our videos to Spotify the next day. So if you're already listening on that platform, you have the opportunity to do that. Now, Robert, biggest kind of thing in the news lately, I had to be negative on the first story, but something I put one of those YouTube shorts together yesterday and got over 1,000 views. And I'm glad in a sense that maybe that indicates that people are a bit concerned with this issue. But
that's what I'm hoping.
Because
this is huge.
But unhappy with what's being planned. And the plan, just to be clear, is that the FCC, the Federal Communications Commission, a few days back, actually approved the launch of sort of a prototype, if you like, a test vehicle to low Earth orbit. I think it's roughly 600 and some kilometers up. And at that height, of course, you're constantly going around the Earth, right? You're not staying over one spot on the Earth. You have to be in geosync orbit for that, much higher up, about 22,000 miles or so. So this is a low Earth orbit. So they're constantly going to be moving in the sky. But what it is essentially is a mirror. And the slide that you see here is obviously an illustration of that. The mirror itself is roughly square in dimension, 18 meters by 18 meters on a side. And the idea is that the company Reflect Orbital is going to launch the spacecraft by the end of this year. That's the current plans. And like I said, this is a prototype, a test, if you like, vehicle. But ultimately what they plan to do is send up on the order of 50,000 of these spacecraft. And actually, they're going to make the mirrors even larger. Like I said, this is just a prototype. So they kept the size, where they can unfurl the Mylar film and stuff. And I'll show you a nice slide of that a little bit later on here. But they're looking at launching, 50,000 of these things in orbit. And the idea is that if you want to have a backyard picnic at night in the dark, okay, and you want to be able to see what's going on, and for some reason you don't have lights, then all you have to do, of course, is to shine sunlight down on the spot of the Earth where your picnic is occurring. And you don't have to worry about electricity. What do you think of that one, Robert?
I think it sucks.
Now, of course, I'm being funny about the example, but you can think of all kinds of things where it might be useful to use this type of spacecraft. For, there are, as we know, places on the Earth that don't receive a lot of sunlight at different times of the year. You can reflect sunlight down on top of those areas. If you're in the military, you can light up the battlefield, for example, for a period of time, do what you have to do, and then, have it move away, and you won't see it any longer. Of course, with 50,000 of these things in orbit, you can all correlate your position and timing and your angles so that you can have multiple spot beams on one general location, not just one. And so there's a whole host of things that you can do. And you might think, this is just it's like having orbital flashlights, those really high powerful one with the LED lights that you can get nowadays, shining down on almost essentially anywhere you want. And these things are going to be put in polar orbit. Now, Robert, you want to say what that means?
Well, one, that's going to be high energy cost, because to break the momentum that they already have, the angular momentum, and get them into that polar orbit where they orbit going across north-south is expensive. But number two, it means that pretty much you can control that there's going to be, with 50,000 of them, there's always going to be over North America some fairly sizable number, which is what they're wanting. And, basically it'll turn, how to put it, it essentially puts them over the meridian, right over the meridian, so that they're always in the sunlight and can redirect that to anywhere you want, one way or another. I hadn't thought about that, but yeah, in polar orbit, there's no getting away from them.
That's the thing, right? The polar orbit allows you to cover essentially every square inch of the surface of the Earth.
Yeah. Wow. So they're not even being nice about it. They're just going straight up corporate terror.
Well, you might wonder, let's be fair, right? Number one, they have responded to complaints. When the FCC made their approval, right away, there were literally hundreds and hundreds and hundreds of comments, all mostly negative about this. And I'll show you a little bit later on that even the American Astronomical Society put together an official document that's submitted to the FCC hearing on this before the decision was made, opposing it and listing multiple reasons why this should not happen. But you might wonder, then, well, how bright are these things? And is it just a little bit? We don't have to really worry about it. It's a little flash of light here and there. Number one, just one of these mirrors would be able to collect as much light as a full moon, but concentrate it into a really small area on the ground. So if any of you have experience at all, maybe with large binoculars or even a telescope, looking at a full moon is hard on the eyes. In fact, with amateur telescopes, and I'm not talking about big giant, $10,000, $20,000 systems here. I'm talking about stuff you can buy for just $100 or more. They have what's called a moon filter. So, Robert, what do you think a moon filter's purpose is for?
Well, it's to cut down the light of looking at the full moon. But there's a reason why, even with a moon filter, we do not observe the moon at full. Because even with one of those filters, it is actually still painful to look at through even a 4-inch telescope, like you said, that you can buy for $200. Yeah. So, no.
So imagine you're driving along the interstate at night, and just by random chance, a beam of this light smacks you in the eyeballs. What's that going to do to your ability to see for a while? If you could.
It kills it. You're going to be night blind.
That's it, right? So that's just one thing. There are lots of other things. Let's just stay away from human beings. Just let's look at the nocturnal animals that rely on a day-night cycle to live on this planet, and all of a sudden now they're going to be exposed to this artificial light. That can disturb a lot of things. That can affect who knows what. I mean, a biologist would be able to tell us more. Does it affect the migratory patterns of certain types of birds? Does it affect insects? Does it affect this? If it gets rid of ticks, I'm all for it. If we can turn, we could turn this thing into a magnifying glass, how kids, especially boys are always saying, when you were little with the magnifying glass, you burnt ants, on the ground type of thing. Well, if we can take this and burn every single tick that roams the planet, I'm all for it. I will contribute money to this thing, you see? Anyways, but seriously, we just don't know. This is just the unknown, right? What is the, what was Rumsfeld said? It's the unknown unknowns that kill you, right? So
Right.
you just don't know what those consequences are.
To me, this is a prime example of the statement made in Jurassic Park. Just because you can, you never stop to question if you should. And this strikes me as that. We can do this, but should we do this? And the answer is the most definitive no. Only somebody whose eye is only on how much money they can make could possibly think this was a good idea.
Now,
so I'm a little annoyed.
Time frame wise, so like I said already, the prototype is supposed to be launched, near the end of this year, and it'll be launched on the Falcon SpaceX rocket. And the reliability of those rockets are such, when it gets launched, there's almost 100% chance it'll be successfully put in the orbit that it needs to be in. Whether or not it unfolds, which it has to do, that's another story. But if it doesn't work on this flight, I'm sure they'll do it again, right? Re-engineering whatever they need to do, and up it goes. And you're not going to get away from it. You see, that's the thing. Yeah. And by 2035, that's when the 50,000 of these mirrors are supposed to be orbiting our planet. And as what I wrote on the slide, turning night into day, essentially, at least for the areas where they're reflecting the light back on the surface of the Earth. So, I don't know. It's so, number one, there's a couple ways you can approach this. So here's one way. What gives some company, which this company happens, Reflect Orbital, is based in the United States. Okay, it's from Hawthorne, California. And right away, if anyone knows a little bit about SpaceX, that's their main base of operation. In fact, it is a former intern of SpaceX that's involved in this company. I checked to see if Elon Musk had anything to do with it, and the answer is no. As far as I know, he has nothing to do with it, except for the fact that he's going to provide launch service, which any other rocket company would anyways, so it's not their fault in that sense. But the thing is, what gives the right of some company in a country to do this to other countries, right? To shine this intense light down on the surface of some country that's, on the other side of the planet from the United States. What gives the right of a company to do that? If you want to shine the light down on some part of the United States or its territory, so be it if the federal government or whatever government allows it. But what gives us the right to shine it down on Australia or on England or France or anywhere else? That's the thing too.
And I guarantee you these things are not going to fold up when they're not over the U.S. and then unfold when they are again. That's not going to happen.
Well,
so you're saying, it'll only be over the U.S., but no, it won't.
Well, to be fair, what they do...
And we're having difficulties.
I hear you're choppy a little bit. But to be fair, Robert, they did say, the company that is, that they will point the mirror away so that it won't, they'll change the alignment slightly so it won't beam the light down on the planet itself. But still, I mean, if some area, some region, let's say some country A orders the light to be shined on some area, it's going to be only that area? I doubt it. With time that takes, to have the change in position of the satellite, all that, there's going to be always a delay time. Just like right. When we do this podcast. And so there'll be regions on the ground that make lots of light, so in fact, these satellites are in motion. Of course, what we'll need is to be able to see how it operates, what's going to actually happen. Right? And then it's too late because these things up there. Unless it goes bankrupt, or something like that. Chances are this thing, they can make money off this, and we can go over, you can see that.
I mean, yeah, I'm sorry, I will disagree with anybody. There is no way this turns into a good thing, And I think I'm gone.
No, you're still here.
Okay.
Now, I was just thinking that...
Because I keep seeing signs on my computer that I'm having internet trouble.
Oh, no, you're still on, Robert. There's a little bit of slowdown in the internet, but we'll press on. Now, The other thing, Robert, is this. I was just thinking of the example where we had such a thing happen back in the early 90s. So this was around 1992. And at the time, Russia put up one of these mirror types, actually a little bit larger than this one. It was 20 meters in diameter, but instead of being a square, I believe it was circular in shape. And they did the same kind of testing, a Mylar mirror that unfolded. and they beamed light down on the surface of the Earth. It didn't last long. I think they had trouble with the unfolding of the mirror itself. I thought it was supposed to be a lot larger than what actually happened. And I remember, back in 1992, actually going outside very early morning. It was going to make a pass where I was living, and actually saw the flash of light from the spacecraft itself. And it was extremely bright, if I remember right. So that's just a slight taste of what we're going to see here. So,
Right.
with the first one being launched at the end of the year, people will be looking for this, the first part of next year, trying to get into a place or be in a place where you might see a flash from the mirror. And then people will kind of get an idea of what it's going to be like in reality. It doesn't look good. It doesn't look good. But anyways,
And what gets me is that people just don't seem to care outside of, it's like your example. If you want to have a picnic outside in the dark, light a bonfire. I mean, that's the whole point, is to be out in the dark around the fire. Come on.
yeah. Yeah, it's
You know?
yeah. I can envision lots of, as I mentioned, I think on the battlefield, if you want to illuminate the position of your enemy and blind them, right? It's a weapon. Then it's an offensive weapon, right?
Right.
Or at least light up their area because you can see where their positions are. If you can't pick them up on infrared or something, which is what mostly you do at night now, then all of a sudden you're blinding them at the same time, and of course there'd be incoming fire to try to wipe them out. So that's only one thing, and it could be lots. Maybe another one they suggested was, what happens if there's like a building collapse? We see lots of that going on with earthquakes recently. Venezuela, example. And at night you maybe don't have enough lighting to be able to see properly. Well, you have one of these spot beams, shining down on that site. That's one idea. So there's always really good things you can use it for, and always really bad things you can use it for, not unlike the internet itself.
Right.
But sometimes the bad things seem to always overwhelm the good things.
Well, I'm sorry, but people with ideas like this always try to emphasize, oh, this is for the good. This is great stuff. And point out all these little things that, oh, it could be used for this, except that what it will be used for. So, color me unconvinced.
Now, Extra Bullet has a very prudent comment. He said, on the bright side, pun intended, you can burn many more vampires. and the thing is about that comment is like, yeah, and you know what they said? By the way, we'll not be able to start forest fires with the beam of light.
Right.
So that means clearly somebody approached him and says, if you shine this on a forest somewhere in northern Canada, will you start another forest fire type of thing? Or what are you saying there, right? Or hey, what a way to smoke out your enemies, light their forests on fire, and then invade them.
Yeah.
Now, what happens if the mirror shines light down on a piece of broken glass that happens to be laying near a kindling, and so on and so forth, right? And then have multiple mirrors shining down at the same location at once if you put enough satellites up. Well, it's nice, here. Yeah, it was nice that the American Astronomical Society, you know, got a hold of this issue and did something about it. It's one thing to you and I to sort of talk about it, you and I and the three people that are listening or something now, but it's another thing to go through the actual exercise of drawing up a physical document. Our audio is going in and out, says Extra Bullet. So that's the internet issue we're having, but there's nothing we can do at this end. Yeah, unfortunately. We'll have to keep going here. So the American Astronomical Society went through the trouble of drawing up this document, and I don't know, maybe they got a lawyer to look at it so you don't get sued or something. I mean, that's what you do typically, right? And then you submit it for consideration to the FCC when they do their sort of talk about what's going on and bring it in front of their board or whatever. But they laid out a bunch of ideas. It's a lot of things that we talked about already, that you don't want to do this. It's a bad thing. In fact, even Starlink and other companies and countries around the world are planning to put up thousands and thousands of these low Earth orbiting satellites. And people are complaining about that too, because obviously now when you take a long exposure image with some of the really expensive telescopes, and I'm talking, some of them on the order of $1 billion or more. Just think of the 39-meter telescope that the European Southern Observatory has. Look out, right? Because one of the main things you're going to do is how to eliminate all those streaks of light from all the image. And it'll be in almost every single image.
Yeah. I don't know what's going on with that. Yeah. Yeah. And pretty much every one shows a satellite going through it. Many over the course of the night have at least two in every frame. We've had as many as four. So people, they say, oh, it's not that bad. Yes, it already is that bad. And you're saying, let's put up 50,000 more of these things. You know, you're not going to be able to see stars at night for this stuff. So, yeah, it's not good. Yeah, right.
Think of different countries, like Russia. I wouldn't doubt it that Russia will put up their own system because they've been kicked off of Starlink, you know. So, and that'll be that many more objects that are being low Earth orbit. So we'll see where all this goes in the end of all. But speaking about SpaceX, last podcast we did a week ago, we talked about the launch that was coming up on that Thursday, so the past Thursday. So I don't know if you had a chance to look in at that, Robert. I'm the space cadet of the. Yeah,
Yeah.
that's weird because now my audio is gone. Not great. We gotta. Yeah, we'll have to work on this. Obviously, we still have issues, Robert.
Yeah, we know that from 4 years ago. So
I thought that
we have these.
I thought we had to solve with this software,
Yeah,
but clearly don't. That's weird. Because,
clearly,
yeah,
clearly we are having. I think this is just pure down internet issues. The internet itself is not stable enough uh, at one or both locations, or to this site that we're using now to host. So, yeah,
yeah. I think internet is the issue today on this. But anyways, continue on.
hey, I won't mention the company's name,
No,
but
well,
par for the course.
yeah. So last Thursday, Starship didn't get launched. So that was flight number 13. In fact, I watched the countdown live, and it counted all the way down to 0, and some of the engines started to light up, and then the whole thing shut down. And that's because obviously there was an issue with the lighting of all the other engines. So now the launch, the recent that I heard the news, is that it's going to be launched this Thursday at the same time. So that's July 23rd at 5:45 p.m. Now, these rockets are important, these type of launches, because it is the Starship that ultimately is going to serve as the lander for the moon. And the next flight of the Artemis mission, Artemis 3, is supposed to test one or more of these landers, one from SpaceX, one from Blue Origins. So if SpaceX cannot get the Starship running at a reasonable sort of high level of confidence and doing all the things it needs to do, that's just going to add more delay to the whole Artemis project itself. So in some sense, everything is hinging on these landers. So these Starship launches are extremely important. So that's why I really pay attention to this.
No, that makes sense. And I probably should, but yeah. Um, who else making landers? Is it Blue Origin?
Blue
and
Origin. That's
SpaceX?
it. That's it. That's the two
Yeah.
that have the contract.
Okay.
And of course, Blue Origin had their delay, right? Their vehicle exploded on test on the
Yep.
launch pad. And the latest I heard is the launch pad will not be ready to be used until sometime in the fall, and it could be late fall near the end of the year. So they've been definitely delayed as well. But things happen. This is rocket engineering, the best way to put it. And there's always things that can go wrong, just like when you're trying to do a podcast. There's always issues that can crop up. Yeah.
Yeah. Well, this is what happens with a live podcast, and you know, I kind of want to keep it live though. We like having the opportunity. Yeah.
Yeah, we'll definitely have to do some more work on this. It works for a while and everything looks great. Then when you get it works great, but that's coming up this Thursday at 5:45 p.m. Central Daylight Time. At some point, Robert, we won't have to do that to say the daylight time, right? If it gets
Yeah.
all passed by the federal government, it'll
Don't
just
get
be
me started
Central
on that
Time.
one.
Anyways, and of course, as I said, this is going to go a long ways into developing a lander that was going to take humans back to the moon. And speaking of the moon, well, one of the launches by the Falcon rocket was to send 2 landers to the moon. It wasn't successful in terms of landers. These were robotic landers, not the ones designed to take humans. It was launched just a couple years ago. And what's happened is the upper stage of the Falcon rocket that did the launching was supposed to re-enter the Earth's atmosphere, if I remember correctly, but it didn't. There was some type of technical issue. So when it maintained this orbit around the Earth, and of course, because it was designed to send landers to the moon, the orbit takes it out towards the moon and then back in again. Well, eventually what would happen, of course, is that rocket will be where the orbit of the moon at the same time the moon is there at that same location. And that's actually going to happen here on Monday on August the 5th. So what will happen is the upper stage of the Falcon rocket is going to impact the moon. So this is estimated to occur early hours of August the 5th for our time zone at 1:34 approximately a.m. Central Daylight Time. Now, the thing is, are we able to see? Because the moon obviously is in orbit around the Earth, so at any given moment in time, it may not be above your local horizon. Therefore, you're not going to see it. So I went into the planetarium program and did a little checking, and sure enough, at least for Grand Forks, on August the 5th at 1:34 a.m., the moon will be 22 degrees above the eastern horizon. It's just starting to rise at that point. So the impact, if there's anything to be seen, which, assuming the weather cooperates, we could potentially see it from here.
Okay. Cool.
So it's one of those things. Mark that on your calendar. August the 5th at 1:34 a.m. Set up your telescopes, look at the moon, and watch. There was a paper that was recently submitted for publication that gave sort of a little summary of what you would expect. And that expecting could be, a blast of the impact itself. It could be viewable. The material that's thrown up above the surface of the moon can get into the sunlight and reflect light that we can see it back here on the Earth. And also, they're going to be looking for the development of a new crater, of course, from the impact.
Yeah.
So potentially you'd be able to see this event from Earth. Wouldn't that be neat? You see a little flash of light at around that time when you're looking through your telescope.
Yeah.
And
works for me.
Yeah.
It'd be kind of neat.
And notice the slide. It shows you the location of the moon where this is going to occur. So it's right near the eastern edge or limb of the moon itself, and the moon will be in the daylight. But still, if it gets high enough, the material, we should be able to see then the reflection of that light from that material of the sunlight back here on the Earth. So we'll see, and then of course you never know till it happens. You might see nothing, or you might see something spectacular. And so in that case, it's worth looking for. Just keep your fingers crossed for the weather. That's the only thing that could cause an issue in all of this. Now, so now the next kind of cool thing I want to talk about is what's going on with the Chinese space program. A lot of times, because they're not as open to the press and the public as we would be here in the United States, for example, a lot of times they do things and they don't make a big announcement or they don't say anything about it until they're absolutely sure everything is okay. And then they'll say, hey, guess what, guys? What? Our spacecraft is in orbit around an asteroid, and we've been there for several days, and everything is going good. In other words, if it would have crashed, you wouldn't have said anything and pretended it never existed? Is that what you're saying?
That's exactly what they're saying.
So it's kind of interesting how this happened. So in this case, this is the Tianwen-2 mission. It is an asteroid not flyby, but orbital mission, at least for a period of time. It was launched on Earth a few years ago. It was designed to fly out to an asteroid, 2016 HO3, go in orbit around the asteroid, but not only that, get extremely close to it and touch it. Stick out its tongue and taste the asteroid. Does it taste like gunpowder or raspberries? What is it? And so what it does, it's going to collect some of that loose material and actually have a reentry module part of the spacecraft that when it flies by Earth, then it'll drop that module to Earth. So it'll parachute down and be picked up, of course, by scientists waiting for it. And then the main spacecraft will continue on its way and try to go rendezvous with another object like a comet or an asteroid, in our solar system. How neat is that?
That's pretty neat. more bang for the buck, you know?
I like this. I mean, Hayabusa did it too, right? The Japanese in their program,
Right.
they did this as well, and so it's a smart
And isn't
idea.
Psyche supposed to do something similar?
Well, that's the asteroid. Yeah, that it's going to Psyche. I don't know if it's going to go beyond that. I can't remember anymore. But Psyche is this one of
Okay.
these asteroids that it's really high content of metal. So it's almost like a
Yeah.
an object that's completely metallic throughout. So that was the big thing about that object. Now, because this spacecraft is now in orbit around this asteroid, we actually can get an image of it, and that's the next slide. This asteroid is extremely tiny in comparison to a lot of the other asteroids. It's only 90 feet in its sort of on average in its size. And you can see the shape of it. It's, what does it look like? A potato chip or something? It's pretty irregular in shape, right? Looks like,
A crisp.
yeah, looks like someone went through your bag of chips and ate the best ones and left things behind.
Right. Left you this little crumb piece,
But it's pretty cool. So it's actually orbiting. The orbit's kind of tough, right? Because obviously you're not going to have a precise distance away from the object because it's irregularly shaped. So you're going to be not in this nice, beautiful circular orbit unless you're constantly using thrusters to maintain that kind of a shaped orbit.
I'm going to sit here and say 90 feet across, it doesn't have much gravity to orbit anyway. So I'm kind of impressed that they got an orbit around it, but I imagine they're burning all kinds of fuel.
Well, you could think about collecting some of the material, right? You can launch a little probe down, like
Yeah.
like an anchor, I don't want to use thinking about killing things,
Okay,
but like
fair.
a hook, let's say on a rope, right?
Yeah, they may have tethered
Yeah,
to it.
you could
Yeah,
launch a tether on it just to disturb the material, blast it out into space, and then
yeah.
fly through that material and collect your sample. So an analogy would be you have to drag your tongue along the surface as you move, right?
Right.
To be able to
I,
to be able to taste it. What was that noise, Robert? Was that your tongue I heard?
I taste the rainbow. Well, okay, the rock.
Anyway, so you could do that, but you're right. It's extremely difficult, and of course, an astronaut, you can calculate how much gravity you can have on this thing, but you can't stand on it.
Oh
I mean,
no.
you can have thrusters to get near it very gently, of course, and you could have a tethered system so that you have these anchors hooking in it to try to keep you there. But if any little push off with your feet and you're gone, you're like your escape velocity at that point, right?
Yeah. I mean, think about it. This thing's got the gravity of about a football stadium.
So you wouldn't say you're orbiting it,
It-
right? You're saying you're just making a close approach. You're rendezvousing with the object.
Right. So if they actually orbited, if they went around it, I'm going to have to say they almost certainly tethered to it, which is impressive in and of
Yeah.
itself. I mean, all the way around, sounds like an impressive mission that, I wish they'd be a little more open and forthcoming about it because it sounds like there was a whole lot of innovation going on.
Yeah, it's pretty cool. So, I mean, it's interesting that you can do that. I like the idea that you can go to multiple objects. That's the
Right.
thing I like.
Then that's impressive on its own
Yeah.
level,
I mean, why you spend all that money to design it, build it, launch it. You hate to see it goes to just this object and then you're done, right? All that money's gone. And you bring back some sample and you
Yeah.
get science out of that. But if you can go around to the solar system, different places, and investigate and do sampling and bring back that material, right? Keep doing that, and maybe over the course of 50 years, you can bring back, samples from 20 different objects or something. What a way to probe the solar system.
That would be amazing. Oh. Mm-mm-mm. See, this is why they need to perfect wetware, and so I can just load my synapses into a computer hardware case and be around for all of this because wow. Yeah.
Yeah, it's pretty amazing in that sense. Okay, so the next thing I wanted to bring up, the next news item, is the discovery of a new planet in the Beta Pictoris system. Now,
Yeah.
we've known of the existence of a planet already orbiting that star. And by the way, the star itself with its planets is about 64 light years away. That's nearby, relatively speaking, of course.
Yeah.
So, you can envision in the distant future we'll be able to hopefully explore the environment, if not with humans, at least robotic type of spacecraft. And if we can get something that travels close to the speed of light eventually, so instead of taking 64 years, let's say it takes 70 years to get there, well, 70 years, you launch it now. We're not going to be able to see that, Robert, by the time it gets there. And then, of course, 64 years to send the data back. So you're talking about nearly 140 years, it's a little over 130 years for, the spacecraft to go out there and then to send the data back and receive it here on Earth. But, if you launched this thing 200 years ago, we would already got the data back already, you see, in our generation.
Yep. You just need to have a rocket program in 1826.
Yeah, you need to. These kind of things take such a long period of time, of course, but you need to start sometime, right?
Yeah, right.
It's not unlike.
And sooner is better than later.
Yeah, and it's not unlike early explorers who went across
Right.
the Atlantic Ocean from Europe, and they're like, well, let's just wait because eventually, in several hundred years from now, they're going to invent this thing called the airplane, and we'll just take the airplane across the Atlantic. That way, I can have dinner and it's only going to take, 5 hours or something, right?
Yep.
But,
But if they hadn't crossed the ocean, who's to say the airplane would have been invented? So
I'm sure somebody would have, Da Vinci, all these people knew about stuff like that, right? Somebody would have invented it,
yeah,
but still, at some point, you're ready to go. You should go, right? I want to do it now. I don't want to wait 300 years for someone else to do it in the distant future. Let me go now, type of thing. Yeah, it's going to take several months. Yeah, I may not make it, but hey, I'm an explorer. I take chances, So, anyways, that's the feeling on that. Now, the star. Yeah, go ahead, Robert.
I was just saying I agree, 100%. And the thing is you're talking about probably 80-90% of the speed of light with your 70 years. The spacecraft itself will probably only experience about 50 years on that. I haven't done the calculations on time dilation in a while. But, you're going to do a flyby. You probably didn't bring enough fuel or anything to slow down and fall into a parking orbit around the star. But, yeah, let's go. Let's do this.
Well, that's that's the argument now of exploring even the nearby star. Alpha Centauri, Proxima Centauri, 4.2 light years away. That doesn't seem too far, even compared to this star. 4.2 is a lot shorter of a distance than 64 light years. But then when do we send a probe to Proxima Centauri? Do we wait until we can send it at 10% the speed of light and that's good enough? Or should we send it when we're ready to hit 1,000th the speed of light? Like, when should we go?
Yeah. And, if you think about it, 10% of the speed of light, that's going to take about 42 years to get there. So I think we're hitting now the sweet spot of we're just being able to do this or contemplate this sort of thing. We could do it. Will 10 years make it where we can do it faster? Maybe not.
Yeah.
It's things we have to think about, though.
Yeah, so I mean, this particular star then has twice the mass of our sun, just in comparison here. It's about 1.5 times larger than our sun, and that puts it in terms of its luminosity. It's about 9 times brighter, intrinsically brighter than our sun itself. So it's a bit.
So something tells me this Beta Pictoris B is not a habitable planet.
Yeah, at least as we know it.
Yeah, call me nutty, but
well, there's always that out, right? As we know it, yeah. We got to always think about that. But
yeah, well, we are dealing with a sample size of 1 when it comes to life, and I think we with Becky, got into that sort of thing. Who knows what other life will look like or be like?
Right. Yeah, I mean that's the thing, right? So, but anyways. that's, you know, what can you? But it's
I want to find out.
well, it's interesting to know when. I like the idea of when do we go, because people have been talking about using blasts of lasers to send little nanoprobes. Right, everything's nano now, right? So let's
Yeah,
send a little nanoprobe towards, Proxima Centauri. Should we do it now, or has the technology like?
then when it's in the right alignment, you kick it into a hyperbolic buzz by the sun, flinging it that direction, get a good enough distance away from the sun, unfurl that huge kilometer scale solar sail, and kick up the acceleration as high as you can go for as long as it'll run, and start your journey.
Yeah. Okay.
You know, let's do this.
Fair enough. Now, to give you an idea of the discovery of this new planet, so here's a slide that kind of gives you a mosaic of different images taken from different telescopes and instruments. For example, we have the VLT, which is in the top left-hand side. In the middle of the panel on the top, the James Webb Space Telescope. The arrow, by the way, in each of those images you see is pointing to the location of the new planet. And you can see that as an enhancement of light. Then we have another JWST image in the upper right. On the bottom, the VLT, then 3 different images. And you can definitely see, that there's something there. It's real. If you take images and you see a spot of light, right? Let's say you take one image. You're not quite sure what it is, if it's an artifact of the image processing, if it's just a random chance you had a few pixels that have, overall brightness higher than the background level, these kind of things. But if you take image after image and it's there, then chances are the object is real.
Yep.
So,
and this is over several months, so I'm not mistaken. It is showing movement, but it's some distance from that star.
Oh yeah, for sure.
It's not a hot Jupiter or something.
No, and notice that the star itself is missing in all these images. That's important to consider here. It's been subtracted away. So in some cases it's an occulting disk, like the images on the bottom, and in the top it's been subtracted from the main image, so you can kind of see the residual or what's left over.
Yeah.
The other neat thing about this is the idea that we've advanced, our instrumentation and our algorithm software to the point where we can do and actually see directly a planet orbiting other stars. That's cool.
Yeah. That is cool. And I'm noticing that the JWST images are near cam.
Yep.
So that's
near infrared.
Near middle infrared. And the reason for that is in the case of star-planet relationships, in the visible part of the spectrum, the contrast difference is about 1,000,000 to 1, if not greater. Whereas when you get off into the infrared, the gap is smaller, and it may be as little as 1,000 to 1, with the star being 1,000 times brighter than that planet. So this is why most of the direct imaging is done in infrared, because that contrast level is down to where we have technology that'll allow us to see through the glare of the star to the planet at that level, at those wavelengths. Whereas visible light, no, we are nowhere near getting that through.
Yeah.
So, yeah, some nice images, nice work. Yeah, it's been a long time coming, because that was one of the big things back in the early 2000s and through the 20 teens. People going, how do we know there are planets there? You you're looking at a bug flying in front of a spotlight or something. Come on. How is that a planet? And we get things like this and are able to say, hey, this matches up with where our transit and radial velocity measurements are saying it should be. And look, there it is. What do you know? So I love this stuff. I'm sorry.
Well, the other cool thing too is nowadays we have the sensitivity where when some of these planets move behind the star relative to us, we get the spectrum of the host star. In other words, we can sample what it's made of, its composition. And
Right.
then when the planet moves towards the front of the star, some of that starlight passes through the atmosphere of the planet and on its way to the Earth. And when that light passes through, grazes through the atmosphere of that planet, that imprints compositional information and other things as well on that spectrum. In other words, we can tell, at least to some effect, in sort of gross, coarse terms, what is the major dominant, constituent in the atmosphere of that planet.
We can sniff its atmosphere, folks. And we're getting better at it every freaking year.
And here's how you know you're right, because if you watch the planet for a while, then it'll go behind the star. That signature in the spectrum caused by the atmosphere of the planet goes away because the planet is blocked by the host star from our point of view. And then when it comes out the other side, you once again see the signature of the atmosphere of the planet, and it's the same as what you measured before on the prior orbit. And it just repeats, over and over and over again.
And so we can layer that signal and build it up over time.
And it also tells you it's not something else, right? It's the same repeatable sort of observation that you're getting.
Yeah. Repeatable. That's the
and
key.
Wait till Europe gets the 39-meter telescope going here in the next year and a half or 2 years from now.
Oh, especially if they start using optics and fiber feeds, so they can put that throughput light right on the sensor.
Robert, the adaptive optics is built into the telescope from the beginning.
Heck yeah.
There's multiple. I was reading something about it not too long ago about the telescope. It is so sophisticated in terms of adaptive optics. In fact, today, on what we call the preprint servers, where people put their papers that are just submitted for publication or just been accepted for publication, there's information about the guide star catalog for the extremely large telescope, the 39-meter.
Nice.
And those guide stars go all the way down to like 21st magnitude. Because you're talking about a large telescope, right? And of course, you got outriggers and small telescopes to help guide it. But yeah, you need something extremely faint. You can't use bright guide stars anymore because the telescope's too large.
Wow. Holy cow.
And with that large of a mirror, even when you're on the ground and using adaptive optics, you're going to have far superior resolution than the Hubble Space Telescope and the James Webb Space Telescope.
Yeah.
So you'll be able...
And like we were just talking about, you're getting these little faint spectra of the atmosphere of these planets when it passes in front of its star. But you're going to get that much better resolution. And year after year after year, you can build up that signal, add it all together. And suddenly we're not dealing with just major constituents anymore in the atmospheres. We're dealing with secondary elements in the atmosphere.
Yeah, and then we're going to be able to observe even more planets that we can't do now because the signature is just too faint. We'll be able to capture it with these type of telescopes.
Right.
And of course,
if we can keep the satellites out of the way. Yeah. Sorry.
Well, you know what ultimately would be nice? Take a 40-meter telescope, put it in space far away from the Earth so you don't have to worry about that kind of a thing. So you got the high resolution of the telescope because you don't have to worry about the blurriness of any part of the atmosphere. You don't need adaptive optics. Number two, then, and you have the large light gathering ability of the telescope because it's so large, so big. So you have very high resolution and very high light gathering ability. And you know that's going to happen in the future. So
Oh yeah,
it's just,
sooner or later. Yeah, it's just right now it's cost prohibitive,
yeah.
or I should say, resource prohibitive.
Well, that's the thing about the Starship, right? The Starship is supposed to be designed so that it's going to be a lot cheaper per pound to send up things in space. So if this system gets perfected, or some future generation is even better, can carry up more and even cheaper, then all of a sudden all of these ideas that we have now that seem wacko type ideas that are, are you'd have to have trillions and trillions of dollars to be able to do them. All of a sudden things change and they become accessible, right? That you can actually do them.
Yeah.
So,
and maybe we could stop dilly-dallying around and get NASA and JSA and ESA and anybody else, the India space program, anybody else who wants to join in, to pool resources, and let's just see what we can pull off.
It's amazing.
Anyway,
yeah, well,
I'm wishful thinking now, but
that's the thing, Robert. So looking at both of us, I mean, one of the things you can do in the future, of course, to be able to partake in the development, whether it's a multi-generation thing or not, is to go to higher learning, right?
Yep.
Go out there, become an engineer, become an aerospace technician, help develop the future of humanity. What noble mission in life. What do you do? What did you do for a living now that you're retired? I helped the progression of humanity to reach the stars and beyond.
And beyond.
How many can say that? I think like I'm talking about Buzz Lightyear or something.
I was about to say, to infinity. Yeah.
Anyways, one way you can do that, of course, is to come to the University of North Dakota, where we have lots of online and on-campus courses that you can take and programs that you can do, and that might allow you to partake in the destiny of humanity. You never know what happens, right? So anyways, we have that here, and it's a beautiful campus, especially this time of the year. Lots of stuff going on.
Especially this.
So if you are in the area or will be dropping by at some point, please give us a visit. And you can see the new STEM building that's well on its way to being put up. Yep. So it's kind of interesting to watch it. I feel like going out every day just to take a picture of it, just to see how things change over time. It'll be kind of amazing, but maybe somebody else is doing that. Who knows? But I have a few pictures. So
yeah.
Anyways,
I hadn't thought about that. It's probably worth taking a few and making a catalog of it.
Yeah, exactly. Yeah. So, Robert, this is the time where we tell people that our next podcast, hopefully, we'll work more on the technical issues. In fact, I saw a message pop up in front of me, and I have something I can actually track down a little bit. So we'll see where that takes us in this seems like endless enterprise of trying to perfect, all of this technology that's involved here.
Yep.
So our next podcast then will be Tuesday, July the 28th. Now, we always leave you with a quote. And today's quote is actually from a publication, so it's really an excerpt in that sense. And this is from the Dark Sky International. And it's related to the first major sort of topic that we talked about today, all about putting mirrors up in space and light pollution, essentially, and all of that. So here's the excerpt. For billions of years, all life has relied on Earth's predictable rhythm of day and night. It's encoded in the DNA of all plants and animals. Humans have radically disrupted this cycle by lighting up the night.
Yep. Absolutely.
With that, thank you very much for watching. Please give us a thumbs up if you can. Subscribe if you haven't subscribed already. And please tell others that we exist. And hopefully we'll do better in terms of production. So we'll see you next time. Thank you.
Bye, folks.